Hey everyone, welcome back to the College Algebra playlist. In the previous two videos, we took a look at linear equations. We showed how to solve linear equations in one variable, and we showed how to analyze linear equations in two variables. Those are equations of lines. And there are three forms that we need to know about, right? There's slope-intercept form, point-slope form, and standard form. And we also took a look at vertical, horizontal, parallel, and perpendicular lines. All right, so in this video, I want to take everything we've learned about linear equations and apply it to some examples. All right, so let's get started. Okay, here we go. Example 49. Here we're asked to solve the equation for x. All right, this is a linear equation in one variable. All right, so we know how to solve these. Okay, we need to isolate x on the left-hand side and get the constants on the right-hand side. Okay, so what we want to do first is distribute this 3 and distribute this 5, all right, to get rid of these parentheses. Okay, when we distribute, we get 3x plus 6, okay, minus 12 equals 5x plus 5. All right. So next we can add these constants together, right? We get 6 minus 12 equals negative 6. All right. And then what we want to do is subtract 5x from both sides. Okay? So when we do that, we'll get everything involving x on the left-hand side. All right? And we also want to add 6 to both sides. All right, when we do that, we'll take all the constants to the right-hand side. Okay? So on the left, we have negative 2x. All right, and then on the right, we have 5 plus 6, which is 11. All right, to isolate x, we need to divide both sides by negative 2. All right, the negative 2's cancel on the left-hand side when we do that, and that leaves us with x equals negative 11 over 2. All right, so that's our final answer. Remember, this is not the equation of a line. This is just a point on the number line, right? It's just x equal to some value, okay? This is a linear equation in one variable. All right, for our next example, we're going to look at a linear equation in two variables, okay? Here we're asked to find the equation of the line passing through 0, 3 with a slope of 2/3. Report the final answer in slope-intercept form. All right? So this is slope-intercept form, right? And remember, m is the slope and b is the y-intercept. All right? So this problem is really easy, okay? Because they give us the slope in the problem, right? They tell us the slope is 2/3, and they give us the y-intercept, right? It passes through 0, 3. This is where the line crosses the y-axis. That means that m is 2/3 and b is 3. Okay, so this is my final answer. Here we're asked to find the equation of the line passing through 2, 3 with an undefined slope. Okay, if something has an undefined slope, that means that it's a vertical line. Okay, so right away we can draw this picture, right? We have a vertical line passing through 2, 3. Okay? The x-coordinate of every point on this vertical line is 2. Okay? So we're going to say that the equation of the vertical line is x equals 2. All right? That's the equation of a vertical line. All right. Next, we're asked to find the equation of the line passing through 1, 2 with a slope of negative 4/5. And we're asked to report the final answer in slope-intercept form. Okay? So what do we have? What do we know? We know that this line passes through the point 1, 2, and we know its slope. Okay? So what we can do is we can use point-slope form, all right, to get started, and then we can just isolate y to get our answer in slope-intercept form. All right? So let's plug in the values. M in blue is negative 4 over 5, okay? And this is the point x1, y1, right? So we have x minus 1 in red, and then on the left we have y minus 2 in green. Okay? So at this point, it's just algebra cleanup, right? We have y minus 2 equals negative 4/5 x plus 4/5. That's what happens when we distribute this 4/5. All right? The negative 4/5. All right, next we just need to isolate y. Okay, so we're just going to add 2 to both sides. And that gives us y equals negative 4/5 x plus 14/5. Okay, 4/5 plus 2 is the same thing as 4/5 plus 10/5. Okay, so when we get a common denominator like that, the result is 14/5. Okay, so this is my final answer. Here we're asked to find the equation of the line passing through 2, 3 with a slope of m equals 0. All right, if the slope is 0, that means that it's a horizontal line. Okay, so we can immediately draw this picture. All right, and we say that the y-coordinate of every point on the line is 3. Okay, so let's say the equation of the horizontal line is y equals 3. All right, and that's our final answer. All right, here we're asked to find the equation of the line passing through 4, 3 parallel to y equals 2x plus 5. Report the final answer in slope-intercept form. All right, so we know the equation of this black line here, right? It's y equals 2x plus 5, and we're looking for the equation of this blue line here, passing through 4, 3. All right? Because these lines are parallel, we know right off the bat that the slope of the blue line is going to be 2. Right? Because remember, we can just look at this equation here, right? We can look at this black equation and say right off the bat, all right, I know that the slope is 2, okay? Because that's the number in the m slot right here next to x, all right? That slope is 2. That means that our slope of our blue line is going to be 2 as well, all right? So we know the slope and we know a point on the line, all right? So let's reach for point slope form here, all right? The slope is 2, okay? So we have m equals 2, and the point on the line, x1, y1, is 4, 3. All right? So on the right-hand side, when we distribute this 2, right, we get 2x minus 8. All right? We almost have y isolated, right? We almost have it in slope-intercept form. We just need to take this 3 to the other side. All right, so we'll add 3 to both sides. And that gives us y equals 2x minus 5. All right, so that's our final answer. Here we're asked to find the equation of the line passing through 1, 3 and 5, 5. Report the final answer in slope-intercept form. All right? So here we have 2 points on the line, all right, but we don't know the slope yet. Okay, so what we need to do is use the slope formula, okay? To find m, right, we're looking for m and b, okay? So to find m, we're going to use the slope formula, which is given right here. All right? It's the change in y over the change in x. Okay, so let's plug in some values to see what we get for the slope. All right? Here I have 5 in green minus 3 in blue, okay? And then on the bottom I have 5 in red minus 1 in black. All right? Those are the values for our 2 points, x1, y1, and x2, y2. All right? So up top, we get 5 minus 3 is 2. And then on the bottom, we get 5 minus 1 is 4. Okay? 2/4 reduces to 1/2. All right? So the slope is 1/2. All right? We don't know b, though. All right? We still need to find b. All right? To do that, let's take this equation and plug in one of these points, right, for our values for x and y. All right? It doesn't matter which point we pick. They'll both work. All right? So we're going to choose this point right here, right? 5, 5, all right? And see what we get. Remember, if it's a point on the line, that means it satisfies this equation. Okay, it makes it true. Okay, so that's why we can plug in the values. All right, we have x in red equals 5, and green, y in green is 5. All right? So I get 5 equals 5 halves plus b. Okay? So to isolate b on the right-hand side, we're going to subtract 5 halves from both sides. All right? And 5 minus 5 halves, that's the same thing as 10 halves minus 5 halves, right? So that gives us 5 halves. All right? So b equals 5 halves. B equals 5 halves and m equals 1 half. All right, so that means we have both pieces that we need to formulate the equation of this line. All right, the equation of the line is y equals 1 half x plus 5 halves. And that's our answer. All right, here's our last problem. This problem is pretty tough. All right, so fasten your seatbelts. Find the equation of the line passing through 2 comma negative 3 perpendicular to 2x plus 3y equals 4. Report the final answer in slope-intercept form. All right, so they give us the equation of this black line here, right? It's right up here. But we don't know the equation of this blue line. Okay, that's what we're looking for. We know that the blue line passes through 2 comma negative 3, and we know that it's perpendicular to this black line. All right, so what we need to do is find the slope of the black line so we can compare it to our perpendicular blue line. All right, this equation is in standard form right now, so we can't extract any useful info from it yet. All right, we need to rearrange it so that we can just look at the equation and find out what the slope is. All right, we need to put it in slope-intercept form. Okay, so to do that, we need to isolate y. All right, so we're going to subtract 2x from both sides. All right, and that gives us 3y equals negative 2x plus 4. All right, so we almost have y isolated. Okay, we just need to divide both sides by 3. All right, the 3's cancel on the left-hand side, and that leaves us with y equals this over 3. Okay? Watch this next step carefully. All right, watch this closely. What I'm going to do is I'm going to rewrite the right-hand side as 2 fractions instead of 1. Okay? Think about the previous videos where we talked about fraction addition, right? When we have common denominators, we have something over 3 plus something over 3, right? That gives us 1 fraction over 3. All right, 2 fractions condense into 1. All right, so I'm just doing the reverse process here, okay? I'm splitting this fraction up into 2 fractions, okay? So let's take this result to the top of the screen because we're not done with it yet, okay? Negative 2x over 3 is the same thing as negative 2/3 x, okay? So now this black line is in slope-intercept form. So we can look at it and say that the slope of the black line is negative 2/3. Okay? That means that the slope of the blue line is 3 halves. Okay, it's the opposite reciprocal. Okay? So now we know what the slope of our blue line is. Okay? So we know the slope, and we know a point on the line. Okay? So we can use point slope form right here. Okay? And we can plug in 3 halves for m. All right, that's the slope. And then for x1, y1, we have 2 comma negative 3. Okay, so we'll plug those values into this equation. All right, that gives us y plus 3 equals 3 halves x minus 3. Okay, that's what happens when we distribute this 3 halves to each piece to get rid of the parentheses. All right. So let's take this result up here and let's isolate y to put it in slope-intercept form. All right, so let's subtract 3 from both sides. And we get y equals 3 halves x minus 6. Okay? So this is my final answer. This is the equation of the blue line. That does it for this video. Thank you for watching, and like and subscribe.